ミッションワクワクワクワクいらっしゃいませここアーニャの部屋ここがキッチンどんなキッチンアーニャレライアーニャにピッ
Have you ever wondered why objects move the way they do? Or what makes them
Stop!
or change direction? Today, we are diving into the rules that govern the motion of everything, from a soccer ball flying through the air when kicked to the planets orbiting the sun. And for that, we are going to turn to a physicist you have probably heard of, Isaac Newton.
Please don't go, please don't go. I love you so, I love you so. Please break my heart.
Imagine sitting below an apple tree and eventually made to solve thousands of simple problems. That's actually what we should be thankful of. With his three laws of motion published in 1687 in his book Principia Newton, we will be able to understand the science behind motion. If you are trying to find an explanation about an elevator taking you up, you standing on the ground, a team pulling a rope in tug-of-war, and everything that involves forces, then you are going to want to use Newton's laws. But before we jump into the theory, let us start a quick challenge. Imagine you are on a skateboard. Will you move without pushing off? No, right? And that can be explained by Newton's first law of motion. Newton's first law is all about inertia, which we call the law of inertia. An object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by a force. In simple terms, it means that things do not change their state of motion unless something else forces them to. An object will keep doing whatever it is doing, whether that is staying still or moving, unless something intervenes. An object has the capacity to resist a change of motion because of what we call inertia. But how do we measure inertia? Let us say we have two balls, a bowling ball and a beach ball. The bowling ball requires more force applied to it to make it move or to stop it from moving than a beach ball would require. Well, it is because it has more inertia and it has more mass. More mass means more stuff, which means it has a bigger tendency to keep doing what it was doing until a force intervenes. And this idea connects us to Newton's second law of motion. Net force is equal to mass multiplied to acceleration, or as an equation, F net is equals to m times a. Net force is the amount of force left over once you have added together all the forces that might cancel each other out. Let's go back to our challenge. If you are on a skateboard and you push us harder, you basically applied a greater force to the ground, which will result in a greater acceleration according to the law. And that's when we can conclude that force is directly proportional to acceleration and its mass. Imagine you are skateboarding in a frictionless area. You will keep moving as the force you exerted is not being cancelled out. If the forces are cancelled out by an equal opposite force, or in other words, the force is balanced out, that is known as equilibrium. In calculating the net force, we always tend to use the gravitational force. The force of the gravity is also known as weight. the unit of force, which is kilogram times meter over second squared. Now, those units can be a bit of mouthful, so we just call it newtons. Weight is measured in newtons and not in kilograms like in mass. It is basically because weight and mass are two different things. Mass is the measure of inertia, while weight is the gravitational force acting downward on an object. But gravity isn't the only force that should be taken into account in calculating net force. This is when we get into the third law of motion. For every action, there is an equal but opposite reaction, which means if you exert a force on an object, it exerts an equal force towards you. This is often called the law of action-reaction. Going back to our example, if you are on a skateboard and you want to move, you push off the ground with your foot. According to Newton's third law, the foot applies a force on the ground, the action force, and the ground applies an equal and opposite force on the foot, and it is what you call the reaction force. By using all these concepts, we can try solving some sample problems related to these three laws. Superman must stop a 120 km/h train in 150 meter to keep it from hitting a stalled car on the tracks. If the train's mass is 3.6 times 10 raised to 5 kg, how much force must he exert? Compared to the weight of the train, give in percent, how much force does the train exert on Superman? So, in sample problem number 1, the first thing we need to do is ilista muna yung given. So, we have 120 km/h, which is yung initial velocity. And yung mass ng train, which is 3.6 times 10 raised to 5. And yung distance na 150 meter. And may isa pa dyan na given, which is yung sabi na Superman must stop a 120 km/h train. So technically, our final velocity would be 0 kasi mag-stop na yung train. So, ang kailangan natin is yung acceleration, which is wala pa tayo. So, we will use the initial velocity and the final velocity to get the acceleration of the train. So, gamitin natin yung kinematics formula na Vf squared is equals to Vi squared plus 2As. Yung Vf natin is 0. I-convert muna natin itong 120 to meter per second. So, para mag-convert, so 120 divide 1,000 divide 3,600. Baligtad. So, 120 times 1,000 divide 3,600. So, yung ating initial velocity daw is 33.33 meter per second. So, 33.33 squared plus 2a. Tapos yung s natin is 150. So, ayan. I-input lang natin sa calculator. Our a would be 33.33 squared plus 2x 150. Negative 3.72963. negative 3.70293. So, bakit negative? Kasi nga, yung final velocity ng train is 0, which means from 120 km per hour to 0, mag-decelerate yung train. So, now na meron na tayong